Welcome 7th grade. Today we are doing lesson 2.3 where we are learning about the constant of proportionality. So let's get going here. We have talked a lot about proportional relationships, recognizing them both in graphs and in tables. So you've learned a little bit about this idea of the constant of proportionality without giving it that name. So what we're going to talk about today is knowing that x and y are proportional if y is always a constant multiple of x. So remember that as you are filling out your note sheet today, if at any point you need to pause this video to get your note sheet filled out, please do that. So here's what we mean by x and y are proportional if y is always a constant multiple of x. You may see an equation like this, y equals 6x. In this case, y is a constant multiple of x because every number I substitute in for x is going to be multiplied by 6. So as my x value increases by 1, my y value is going to increase by 6. It's going to be 6 times as big as my x value. So this would be an example of a proportional relationship. And we're going to look at how to find this constant of proportionality, this ratio. So this constant multiple we have already been learning about. We just haven't given it this name yet. So the constant multiple is y over x. This is your constant of proportionality. The good news is we've already learned about this because when we were examining relationships in tables, this is what we looked for. In our XY table, we added a third column where we compared the ratio of y to x. And we said if we have a constant ratio of y to x and they all reduce to the same ratio, then we had a proportional relationship. So here's a new piece for you today. As we begin working in word problems, you're not always going to know which is your y value and which is your x. So here is a trick for helping you remember. So if my constant of proportionality is y to x, then we can remember that y is our dependent variable. This variable depends on the other one. So this number changes depending on what my x value is. And we saw that in this equation. Y depends on what number I put in here for x. If I put a 0 in for x, 6 times 0 is 0. If I put a 1 in here for x, 6 times 1 is 6. So y depends on x. So that's why we call it our dependent variable. Your x then is going to be your independent variable. This is not influenced at all by y. Here's what that looks like in a word problem. Let's look at example 1. The weight of the stack depends on the number of books in the stack. So right off the bat, I'm noticing this word depends. This is going to help me see that the weight of the stack, this must be my dependent variable because it depends on the number of books in the stack. So this will be my dependent variable, and the number of books will be my independent variable. So I need to identify the constant of proportionality. That's what the question's asking me to do. I need to find this value of y to x. And then I'm going to use this to find the weight of 11 books. So let's get started. I know my constant of proportionality is y to x, which means dependent to independent. And we've already identified that the dependent variable is the weight of the stack because it depends on the number of books. So that's my independent variable. So let's go ahead and substitute those values in. The weight of the stack I can see in my picture. Looking at the scale, it is 15.75 pounds. That's my weight. And now I need the number of books. 1, 2, 3, 4, 5, 6, 7, 8, 9 books in this stack. So now I have my constant of proportionality. But let's reduce this and let's simplify. So if I take 15.75 divided by 9, I'm going to get down to a unit rate. So 15.75 divided by 9 tells me that it is 1.75 pounds per one book. So you'll remember that a unit rate always has a denominator of 1. So it's 1.75 pounds per book. That is my constant of proportionality, reduced to lowest terms. What I'm looking for was my constant, and now I'm going to use it to find the weight of 11 books. So I'm going to take this unit rate, and I'm going to write it in a proportion, because I can use equivalent ratios to help me solve this problem. So now I'm asking myself, how do I turn one book into 11 books? I'm going from small to large, so I need to multiply. 1 times 11 is 11, and to keep my proportion balanced, whatever I do to the bottom, I need to do to the top. So I will also multiply 1.75 times 11, which gives me 19.25 pounds. So the weight of 11 books then is 19.25 pounds. Great job, you have solved your first problem using the constant of proportionality. Let's practice it again on the second example. However, before we get started on this one, I want you to come down to the bottom and cross this out. This second problem is not dealing with the weight of stacks and pounds of books. This problem is looking at shoe boxes. So please excuse that typo. On example 2, each shoe box is the same height. The height of the display depends on the number of shoe boxes in one column of shoe boxes. What is the constant of proportionality? So here's what I'm looking for. I need to find my y to x. Okay, so to do that, we'll remember that the y is my dependent variable. So let's figure out which variable depends on the other one. So let's look at what we know. I know that each shoebox is the same height, and that all together these are 45 inches. I know that the height depends on the number of shoeboxes. So the height is going to be my dependent variable, and the number of shoeboxes is going to be my independent variable. So height is going to be my y, number of shoeboxes is going to be my x. So let's go ahead and substitute in here our height. So I know the height of the stack is 45 inches, and the number of shoe boxes in each stack is 1, 2, 3, 4, 5. So now I have my constant of proportionality, but it's not yet in lowest terms. So let's go ahead and reduce. 45 divided by 5 is 9. So that means that there is 9 inches in one shoebox. So that gives me the height of my shoebox. So 9 inches to one shoebox is my constant of proportionality. I think you're getting the hang of it, so let's flip over and try some more examples on the back. Example 3 is a baking question. So you have a recipe that calls for 2 cups of flour to make 3 dozen cookies. Your friend has a cookie recipe that calls for 3 cups of flour to make 60 cookies. Are the constants of proportionality the same for the 2 recipes? Are the recipes for the same cookie? How do you know? So as we look at our constant of proportionality, remember that's going to be y over x. Our dependent variable over our independent variable. So the number of cookies I make depends on how much flour I use. So the number of cookies is my dependent variable. The amount of flour is my independent variable. So as I'm comparing two recipes, mine and my friend's, the constant of proportionality for my recipe says up here that I have 2 cups of flour to make 3 dozen cookies. I need to know that 3 dozen means 3 times 12 because there are 12 cookies in a dozen. So 3 times 12 is 36. So my recipe allows me to make 36 cookies using 2 cups of flour. So if I'm going to take my constant of proportionality and reduce it to lowest terms and simplify, 36 divided by 2 is 18. So my constant is 18 cookies per 1 cup of flour. For my friend has a recipe that calls for 3 cups of flour to make 60 cookies. So 60 cookies per 3 cups of flour. If I reduce this to lowest terms, 60 divided by 3 is 20. So that tells me 20 cookies per 1 cup of flour. So let's come back up to my question. Are the constants of proportionality the same for the two recipes? Definitely not. 18 cookies per cup of flour, 20 cookies per cup of flour. Not the same. Are the recipes for the same cookie? We must be using different recipes if we are using a different ratio. Our constant of proportionality would have come out to be the same when we reduce to lowest terms if we were using the same recipe. All right, and finally for you to work on your own, I have one last got it question. This is a chance for you to see if you've got it. After you finish this question, you can log into Digits and do your 2.3 homework. You run on a treadmill daily at a constant speed. On Monday, you ran 2.25 miles in 22.5 minutes. On Tuesday, you ran 2.35 miles in 25 minutes. Are the constants of proportionality the same for the 2 days? How do you know? So to set up your problem, we're going to look at Monday and Tuesday separately. So our constant of proportionality is y to x. And remember, y is your dependent variable and x is your independent variable. So you are looking for which value depends on the other. So the two values we have are miles and minutes. So you need to identify which one depends on the other. Does the number of miles I run depend on how many minutes I run, or vice versa? So take a second to set up your two ratios, reduce them to lowest terms, and then check to see if they are the same. Good luck!